Roughly 7 billion light-years away, two colossal structures, each one a collection of thousands of galaxies bound together by gravity, crashed into each other at a speed and mass so extreme that according to our standard model of the universe, an object like this should never have formed at all. Not rare, not unlikely, essentially statistically forbidden. Astronomers call it El Gordo, Spanish for the fat one, and the name fits. It is the largest, hottest, and most massive galaxy cluster collision ever found at its distance, existing when the universe was only about half its current age. Two enormous subclusters, each one containing a mass equivalent to over 1,000 trillion times the mass of our Sun, are caught in the act of slamming into each other at extraordinary speed. Here's the problem. In 2021, a team of physicists at the University of Bonn, led by Elena Asensio, calculated exactly how likely it would be to find an object like El Gordo if the standard model of cosmology, called Lambda cold dark matter, is correct. They built a massive computer simulation of the universe following that standard model and searched for anything resembling El Gordo's mass, speed, and timing. The result was almost unbelievable. The probability of finding a collision like this was so low that, statistically, you would expect to find only one El Gordo-like object in a simulated volume of space roughly 1 billion times larger than the actual patch of sky where El Gordo was found. In physics, that kind of statistical failure gets measured in standard deviations, and this one came out at 6.2 sigma, a level of certainty so extreme it would normally be treated as a confirmed, undeniable discovery in almost any other area of science. For a while, some researchers hoped this discrepancy might simply fade away as better measurements came in, the way anomalies sometimes do. It didn't. In a follow-up study, using an updated and far more precise mass estimate that reduced the uncertainty in El Gordo's mass down to roughly 10%, the team found the tension with the standard model remained highly significant, no matter what plausible collision speed they assumed. Even giving the standard model every reasonable benefit of the doubt, El Gordo still shouldn't exist in the universe our best cosmological model describes. So what could actually explain this? There are a few honest possibilities. It's possible our estimates of the cluster's mass or collision speed are still off in some way not yet identified, and better data will eventually resolve the tension. It's possible that standard cosmological simulations, limited by the sheer computing power required to model volumes of space this vast, simply aren't yet capable of capturing genuinely rare, extreme events like this one, even if they are possible within the standard model. And it's possible, as the Bonn research team themselves argue, that this is more direct evidence pointing toward the same conclusion we explored when we covered MOND on this channel, that gravity itself may behave differently than the standard model assumes at these enormous scales, removing the need for El Gordo to be quite so statistically miraculous in the first place. It's worth being upfront that the team behind this finding, including physicist Pavel Krupa, has a long history of favoring modified gravity explanations over dark matter, so this result should be weighed as one perspective within an active, ongoing scientific argument, not a settled conclusion the entire field agrees with. Other cosmologists continue to defend the standard model, arguing that rare, extreme statistical outliers are exactly the kind of thing you'd expect to occasionally find if you search enough of the sky for long enough. What makes El Gordo worth paying attention to, regardless of which side turns out to be right, is that it fits a pattern we've now seen repeatedly on this channel. Structures that are too large, too massive, or too fast for their place in cosmic history, showing up again and again across completely different types of observations, from early galaxies to early black holes, to now colliding clusters of galaxies that shouldn't have had the time or the material to build the momentum they're carrying. Either our simulations of the universe are missing something about how structure grows, or the underlying physics of gravity itself needs a second look. Both possibilities would be genuinely significant. And right now, 7 billion light-years away, two enormous clusters of galaxies are still colliding, indifferent to which explanation eventually turns out to be correct. What do you think? Is El Gordo a statistical fluke waiting for better data, or another sign that something in our model of the universe needs to change? Let me know in the comments. Subscribe, because next time we are finally covering quark stars, a theoretical object even denser and stranger than a neutron star, made of matter crushed so violently that neutrons themselves are believed to break apart entirely.